Okay, someone on the mic can see the textbook?
Yes, can see, teacher.
Okay, thank you. So today we will start new chapter. Okay, so this is a last chapter. Okay, kinematics of a linear motion. The old syllabus, KSSM syllabus, is called motion along straight line. Then your KSSM, they changed the title, become a kinematics of a linear motion. Okay, so today we will start with this. Okay, 8.1. Okay, sorry. As I said just now, it been restart again for my laptop. So I don't use the digital pen. Okay, so I have to. Where do I go? Okay, you have your textbook. It's a page 252. Okay, can see textbook, right?
Can, teacher.
Okay. So now you see I write very slow and my writing is very ugly. Okay, so index for today. Today is 5th. Okay, displacement, velocity, and acceleration as a function of time. Okay, so first of all, actually, you have to know displacement, velocity, acceleration. These three are the vector. Okay, vector quantity. Yeah. So we will continue. Okay, you look at this diagram. You look at this diagram. Okay, this is a teacher. Okay, and then you go to this paragraph. Okay. Because just now as I mentioned just now, displacement is a vector quantity. Therefore, you will have direction. Okay, you have a magnitude and also you have a direction. Okay, so we see on this case, the diagram shows the initial position of a teacher standing 1 meter on the left of a fixed point O. Okay, and then always you will have a fixed point. Okay, so here you have a fixed point O. This is a fixed point O. Initially, okay, at the beginning, okay, the teacher standing 1 meter on the left. Okay, then the teacher moved to the positions of 3 meter to the right. Okay, what can you say about the position of teacher in relation to the fixed point O? Okay, if O is a reference point, so you see, this kind of questions, you always will have a reference point. Okay, and then mostly they will label the reference point as O lah. Okay, but some case is not. Okay, the teacher is standing 3 meters to the right of O. Okay, her displacement is positive 3 meters from O. If right hand side, the displacement will be positive. Okay, then left hand side, the displacement will be negative. Okay, which is S is equal to 3 meters. Okay, S is the displacement. Yeah, S is the displacement. Okay. When the teacher is 1 meter to the left of O, her displacement is negative 1 meter from O, which is S is equal to negative 1 meter. So when the questions are, they give you this, okay, S is negative, you have to know what's the meaning. S is positive, what you have to know what is the meaning. Okay. When she is at point O, her displacement is 0 meter, which is S is equal to 0 meter. Okay, so this paragraph is very important, okay, to help you to understand the meaning of the displacement. Okay, so this one you may copy. Displacement S of a particle from a fixed point is the distance of the particle from the fixed point measured on a certain direction. Okay, then what is different in between displacement and the distance? Okay, distance. Okay, displacement is a vector quantity. Distance is a scalar quantity. Okay, mean distance we don't care is on the left or on the right. Okay, and then usually distance is referred to the total path travel, total distance travel, or total path travel. Okay, means it go here, then it go here, then it go here, then it go here. You measure from here to here, what's the distance, and then here to here, what's the distance, and then again here to here, what's the distance, and total up, total distance travel. The distance refer to this. Okay, but displacement is different. Displacement is where is the location, refer to this fixed point. Is on the left of the point or on the right of the point. This one we call it displacement. Okay, so you must be very clear. Okay, what is the difference in between the displacement and the distance? Yeah, so this is about displacement. Okay, we go to the next one. Okay, this one also you can copy. Okay, if O is a fixed point, the movement of the particle to the right is positive, then the displacement is negative, S smaller than 0, meaning what? Meaning the particle is on the left of point O. Okay, the displacement is 0, S equal to 0, meaning what? Meaning the particle is on the point O. Then the third one, the displacement is positive, S greater than 0, meaning what? Meaning the particle is on the right of point O. Okay, so these three things you must know. Okay. Now we look at this example 1. When you look at example 1, you will think, hey, actually not difficult. This kind of question actually not difficult. Okay, but yes sometimes K-BAT question they can set become quite difficult But if basically actually this question okay, unless sometimes they are asking more than one particles, then that kind of questions are maybe a little bit difficult. Okay, you look at example 1. A particle moves along a straight line and passes through a fixed point O. The displacement S meter of the particle t second after it start moving is given as S equals to 4 plus 8t minus t squared. Okay, so the displacement is given in a function of time. This is our title. Okay, refer back to our title today, or the index for today. Displacement, velocity, and acceleration as a function of time. This is a meaning. Okay, so here you see the question given. Okay, the S the displacement as a function of time. Mean here is the time, t. Okay, t is the time. Calculate the instantaneous displacement. Instantaneous displacement means displacement at that time. Okay, the meaning, okay, here. This one after I will go through review. Okay, what's the meaning of this instantaneous displacement? Instantaneous displacement means the displacement at a certain time. This is the meaning. Okay, so we refer back to this. Okay, in meter, and determine the position of the particle from point O when t equals to 0. Means they want to know when t equals to 0, the certain time, okay, means here the t equals to 0, what is the displacement? This is the meaning. So very simple, you just replace the into this function, the t as 0. Here, so you get the s is 4. Okay, after that you got to determine the position. You got to say, okay, the position of the particle from the point O. Okay, the particle is like, just now that like the teacher that things moving one, we always say it's a particle moving. Okay, so if s is 4 means what? Positive means on the right, on the right hand side of the fixed point O. Left, this one wrong, okay, this right, okay, your textbook got mistake, okay, the particle is located 4 meters to the right from the fixed point O when t is 0. Okay, this is part A. Now how about part B? Okay, when t is 10, okay, so what is the displacement? Okay, so replace here the t is 10, so the displacement is negative 16. Same thing, determine the position. So you got to say the particles located 16 meter from, you got to say to the left, they miss out, okay, to the left because it's negative. Okay, to the left, okay, from the fixed point O, okay, when t is 10. Okay, so you see this kind of question, I think you can do, just substitute, okay, the t inside these functions, okay, can get the answer for the s already. Okay, now if this function is given, you look at this function. This function is a t squared. It's a quadratic function. Okay, so can you draw the graph? No problem, right? This one you're from 4. You have learned quadratic function, how to draw a graph. Okay, then we would like to analyze afterwards. Okay, the graph means what? Okay, we see this example. This method actually I not really like it this method. Okay, afterwards I will tell you why. Okay, but temporary we just follow this method Now the main idea is to get the graph Okay, so copy and complete the table below. Okay, so when t is 0, you substitute here is 0. Okay, so this is 0. Okay, when t is 1, so 1 squared minus 3 times 1. Okay, this is negative 2. Okay, so I direct straight away give you the answer. Okay, when substitute t is 2, when substitute 3 is 3, and when substitute t is 4, you get 4. Okay, so this is the answer. Then based on this, okay, we draw graph first. Based on this, okay, you draw this graph. Okay, when t is 0, is 0. When t is 4, is at 4. Okay, when t is 3, is at 0. When t is at 1, is negative 2. 2 also is negative 2. But you have to know, okay, because this is quadratic, it will go down some more and then come out. Okay, because here they didn't mention exactly here is what. Okay, so as I say, this method is not good because this method, it will not show you this value, the minimum or the maximum point or the value. It doesn't show it. So this method is not actually not a good method. Okay, so if you want, after using this, you have to find this actually. Okay, so you know that this is the negative 2 and this is negative 2. Then the middle here, the middle point of the 1 and 2 here is 1.5, will give you the minimum of the s. Then you substitute t as 1.5 to get the minimum of the s. Okay, so after you get the graph, okay, and then sometimes they will ask you to construct the graph, and then you got to analyze from the graph also. Okay. Okay, now we look at this. Okay, another one other than the graph, you also need to construct the number line. Okay, if the question didn't ask me to construct the graph, I will rather to construct the number line. Okay, number line, I feel that will give me a clearer picture how the particle move actually. Okay, so we see when t is 0 is at 0, mean here is a fixed point O. So when t at 0, the particle is at here. Okay, then after that, when t is 1, it go to -2. -2, so from here, the particle move to here, -2. Okay, -2 means 2 meter to the left of a point, fixed point O. Okay, after that, actually it goes some more, but this one, as I say, the table didn't show, it goes some more. Okay, after that, it will stop for a while. Okay, when stop for a while, remember at the time the velocity is 0. Okay, I will explain to you why. Okay, you see this particle is very, how to say, very follow the rules one, Okay, after it stop for a while, the next thing it will do is not continue to the same direction. Okay, you see before that is going this way. The particle from here move to here, it means it move to the left. Okay, and when you stop a while, okay, it will turn direction. Okay, turn direction, it will go this way. Go to the right. Okay, so you remember all the particles the same. Okay, when you stop a while, it will change direction. Okay, it start from moving to the left, it will change to moving to the right. If you start with moving to the right, it will change to moving to the left. This is the criteria of the particles. Okay, so after that, when t equals to 2, it goes somewhere already. Yeah, when t equals to 2, okay, it come back here, it's at this location. Okay, 2 meter from the left of point O. Then go some more, when t is 3, okay, it come back to the point O. Okay, then when t is 4, is at the positive 4. So it's on the right hand side of the point, fixed point O. Okay, you see the diagram they draw in this way, not because of the particle really move in this way, you don't get mistake, Okay, actually the particle is moving exactly fall on a straight line. That's why it's called linear. Okay, so if really you want, okay, I can show you. This is a particle start moving. I use highlight. Okay, I use highlight, don't know, see. Okay, when t is 0 is here. When t is 1, it move. Highlight cannot see now. Okay, maybe I put thicker a bit. Okay, start over again. Okay, start here. When t is 0, it move along straight line now. Okay, when t is 1, it reach here. When t is 1.5, it come to here. Then it stop for a while, then it turning back. When t is 2, it come back here. When t is 3, it come back here. Then when t is 4, it go here. So you see, actually the particles is always is on this line only, linear. It will not like this diagram, This one maybe you will misunderstanding it, You move this way, No, actually the particle it move like this only, move along this line only, linear motion. Okay, but why you have to draw in this way, Why you have to draw in this way? This way, dot dot dot, and then dot dot dot. This one is for you to see. Okay, actually the particle, move this long already, and after that it turn and then come back here. Okay, but actually the real one, what happened? The real one is actually the particle is only move like this, and move like this. Okay, if I draw in this way, I don't know, I don't know where is the particle moving, because all four in this line, Can you see? I didn't put, even I put arrow, then after that I put arrow like that. It's so messy, all everything fall in one line, so you cannot see anything. This is why you need to draw in this way. But you got to know the particle is not moving in this way, like a U-turn. No, the particle actually is moved in this way, along a line only. Okay, so this is very important. Okay, now we go to this. Okay, this one done. Okay, now we go to this, these three. Okay, this is typical. Okay, the displacement is negative, okay, for the t0 to 3. For the t0 to 3, the displacement is at the negative. Okay, so the particle is on the left of fixed point O, okay, or below the t-axis in this interval. This is the t-axis. This is the t-axis. So below the t-axis, the graph, okay, below the t-axis. Okay, this is the meaning for the first dot. Second dot, the displacement is 0 at t equals 0 and t equals 3. Okay, the particle is at the fixed point O, or on the t-axis, So this point and this point. Okay, the third dot, the displacement is positive for t greater than 3. Okay, so t greater than 3, this part, positive, okay, or above the t-axis. Okay, so this one done. Okay, now we go to example 2. Okay, example 2 is the same thing. They want you to draw the graph, okay, and the number line. Okay, so a particle moves along a straight line and passes through a fixed point O. Okay, you see, always the sentence start this way one. Move along a straight line, passes through fixed point O. Always the sentence will start in this way. Okay, its displacement s meter t second after passing point O is given by, okay, so this is the function given, okay, for t, okay, so from 0 to 5, okay, means your graph, after this, you're going to sketch from 0 to 5. Represent the displacement of the particle by using these two. One, number line. Second one, the displacement time graph. Okay, as I said just now, I don't want to use the table, okay? The 0 to 5 table, I don't want to use this table. Okay, because this one actually will not show me, sometimes will show, sometimes will not show me the maximum or the minimum point. In this case, it will show because number, okay, so lucky that 2, okay, give you the maximum point of 4, okay, when t is 2, okay, but sometimes it's not long, like example just now, this activity, okay, you see the maximum, you cannot see. I don't know where is the, sorry, not maximum. I don't know where is the minimum. Here, I don't know what. Question mark. Oh, I don't know what is this. Okay, so I don't like this method. Okay, we don't want to use this table method. So if you don't want to use this table method, you still remember how you, if you want to sketch how to say, a quadratic function. Okay, so it's very simple. First of all, I will need this. Okay, the starting point and the ending point. Okay, or the starting time and the ending time. Okay, so first of all, I will need when t is 0. Okay, so the s is 1. Okay, so you replace into this function, the s is 0. Okay, the starting time. Okay, the ending time, t is 5. Okay, when t is 5, substitute here. Okay, the s is -5. I will assume you got no problem in substitutions. Okay, so I have these 2 points already. Then I need to know when s is 0. Okay, when s is 0. Usually like this when t is 0, find it, and then when s is 0, find it, okay? When s is 0, you're going to find the t value. Okay, so 4t minus t squared, okay, equal to 0. Okay, so I factor out t. So 4 minus t equals 0. Okay, therefore, t equals 0, 1 point. Okay, and then t equals 4, 1 point. Okay, so at these 2 points, okay, the s is 0. Okay, so actually in the, how to say, in the table, you can see all this information. Okay, this is if you are lucky, okay, you get this kind of function, but sometimes it's not, no? Okay, sometimes this one is not whole number, then, but you are using all the whole number, then your graph is not accurate, no? Sometimes you want, you need some information from the graph, it tend to be like not accurate, no? Okay, so I have done when t is 0, when s is 0, then one more thing is I want to know the turning point, no? Okay, the turning point, what you can do dy dx if you want. Okay, in this case, it's ds dt. Okay, ds dt. This is, you know why you will say, hey, why differentiate again? But you don't worry, afterwards, this chapter is all about differentiation and integration. It's just beginning of the chapter, they didn't put in yet. So you don't have to say, I don't like differentiation. If you don't like differentiation, means that the whole chapter you don't do. But it's very sayang, I can tell you, because the differentiation and the integration in these chapters all senang-senang saja. You will not seeing the chain rule, product rules, quotient rule, no. Okay, don't have. Yeah. So I start now. 4t, you differentiate 4t, you get 4. Okay, reduce the power Okay, you differentiate t squared, you get 2t. Okay, and then after that, let it equals 0. This is for you to find the maximum point. Okay, therefore 2t, you forgot already, this is another time you do divisions. Okay, it's 4. Then t, 4 divided by 2, you get 2. Okay, so t equals to 2 at this time, okay, maximum happen. Okay, why maximum? Because this is negative for the A, so set phase. Okay, so maximum happen. Okay, so when t is 2, okay, one more thing, when t is 2, you find the S. Okay, so substitute inside here, you get the S is 4. All this information, okay, is enough already for you to sketch the graph. Okay, so I based on this graph, okay, first point 0, 0, I mark here. Second point 5, negative 5. Okay, 5, negative 5. Remember, try to even though it's sketched, try to use a uniform scale. Okay, next, when s is 0, got 2 points. T is 0 and t is 4. Okay, t is 0, 0, 0, I got already. 4, 0. Okay, this is another point. Okay, then the maximum happened when t is 2, s is 4. Okay, then you just join. Remember, cannot join with ruler. This is quadratic. So you try to draw out the shape of quadratic. Okay, but all the important point I have plot it. So follow the important points. Okay, and then sketch it. Okay. Okay, so this is the graph. Okay, remember to mark all the important points on the axis. Okay. Okay, next, the number line. Okay, how to draw the number line? Okay, so we start with when t is 0, s is 0. Okay, so when t is 0, s is 0. Here is the fixed point O, fixed point O. Okay, after that, what information I have? I see this one done. Okay, next point, I will go to this next point. Okay, when t is 2, s is 4. Okay, so when t is 2, s is 4. 4 is on the right hand side of the O. Okay, at this point it will turn already because I know this is maximum. Okay, so it will turn. So first it will go here. So you see, for me, the t equals 1, t equals 3, the s is 3. For me, it's not important. Okay, important is this. I have to know when it's going to turn and at where it's going to turn the particle. So I know when t equals 2, s equals 4, okay, it happened here, the particle turn. Okay, turn to the left. Now move to the left. Move to the left. Continue, move to the left. Okay, and then lastly, this one. Okay, the final time when t is 5, s is at -5, means on the left of the O. Of the left of the O. Okay, if this question they ask, okay, what is the total distance traveled for this particle from the time t from the 0 until t equals to 5. Okay, so you see, from here to here, this is 4, right? Okay, from here to here, okay, it had traveled 4 meters. Then from here to here, okay, before that, from here to here, this is 4 to 0, another 4 meters. And after that, go to the left hand side, from 0 to -5, here is another 5 meters. Okay, you see, distance traveled, all the negative are not important. We don't care one. Okay, so distance traveled is 4 plus 4 plus 5. See, 4 plus 4 plus 5. So the answer is 13 meters. If the question asks for distance traveled. Okay, I hope so far still okay. Okay, now we come to velocity. Okay, displacement finished already. But displacement and the velocity will have how to say, is related. These two are related. Okay. Okay, we look at this velocity. Okay, velocity they denote by v. Okay, is the rate of change of displacement. Rate of change. When you see this rate, again, it will related to the t time. Okay, while speed is defined as the rate of change of distance with the time. So speed is a scalar quantity. Velocity is a vector quantity. Okay, because velocity is related to displacement. Okay, speed is related to distance. Okay, it follows. Distance is a scalar quantity, therefore speed also is a scalar quantity. Displacement is a vector quantity, therefore velocity also will be a vector quantity. Okay. Okay, so now you see what is velocity. Okay, velocity is the rate of change. Okay, so V, rate of change. When you see rate, it must be due with time. Okay, rate of change of displacement. So S displacement. So ds dt. Okay, is the velocity. Okay, you can either write ds dt, you can write this also. Okay, the difference of the s divided by the difference of the t. This one, when you refer to the graph law, okay, and then this one actually is the gradient. The velocity actually is the gradient. Gradient of the which graph? Just now that type of graph. Gradient of, okay, the displacement time graph. All this is very important. You must know. I cannot write properly, and write very slow. Okay, then same thing, when you see this word instantaneously, in instantaneous velocity. It seems like just now the instantaneous displacement. Okay, instantaneous velocity is the velocity at a certain time. Same no? Just now also. Okay, displacement at a certain time, we call it instantaneous displacement. Yeah. So we look at this. Okay, we look at this graph. Okay, so this graph is the S and the T, displacement time graph. Okay, the function is this way, 8t minus 2t squared. Okay, so now, just now we say already, velocity is the gradient of this type of graph. Okay, now, because this is a curve, so it's the gradient of the curve. Okay, so gradient of the curve, always you've got to refer to a certain point. So you can see very clear actually from here to here. Okay, this type of a shape of the curve, the gradient is positive. Okay, then when come to here, maximum point, you still remember? Okay, maximum point, the gradient is 0. Then after that, when the shape of the graph of the curve is something like this, come with this one, okay, the gradient is negative. Okay, so now we go through these 3 points. Okay, the gradient of tangent, okay, from 0 to 2 now. Okay, from 0 to 2, from here to here, but not including 2. Not including 2, you see, no equal sign here. Okay. Okay, it is positive. Okay, the gradient is positive, as I said just now. Okay, so the velocity of this is refer to a pupil running, I think. So the velocity is positive. Okay, where v is greater than 0. Okay, the pupil is running to the right from O. To the right from O, because okay, one more thing you need to know is velocity positive means the motion is moving to the right. Okay, motion. Okay, the direction of the motion is to the right. To the right. This one also you have to know. Okay, at t equals to 2. Okay, here. Okay, the velocity is 0. Okay, so what's the meaning? The velocity is 0. Means not moving. So it's instantaneously at rest. Okay, before changing in motion. As I say just now, when we do the displacement, okay, when the particle it rests for a while, it will change the direction. Just now moving to the right, now it will change the direction, move to the left. Okay, now you see the gradient, okay, for t greater than 2, okay, the gradient is negative. So the velocity is negative, smaller than 0. Okay, the pupil is running to the left, to or in this direction, to the left. Okay, now we look at the number line. What is the meaning of running to the right, or motion to the right and motion to the left? Okay, you see, the particle is from here, it go to here. This one we call it motion to the right. Okay, then it stops for a while at this point. After that, it goes this way. Start from here onwards. Start from the t equals 2 onwards. The motion is to the left. Can see or not? What's the difference in the positive and negative for the v, and what is different for the positive and negative for the displacement? Displacement is reference point here, the O. Okay, if the particle is on the right, okay, the displacement is positive. If the particle is on the left, the displacement is negative. Okay, I point out here. Okay, you look at this point. You look at this point. When t is 3, when t is 3, when t is 1. Okay, when t is 3 and when t is 1, okay, their s is the same. Okay, here their s is 6. Yeah, s is 6. Okay. Means when t is 1 and when t is 3, okay, the displacement, the location, the position of the particle is on the right hand side of the O, 6 meters away from the O on the right hand side. But when t equals to 1, the velocity is positive 4, means the particle is moving. The direction is moving, pointing to the right. But when t is 3, okay, the velocity is negative 4, okay, the particle now already turned direction, okay, now is moving to the left. Even though the displacement now is still at positive, but the velocity is negative, it means that the particle is pointing to the left. This is the meaning. I hope it's clear. This part is very important. Okay, if you get confused on this part, then after that, many questions you are very confusing. Okay, so you have to know what's the meaning for the V positive, V negative, and what's the meaning of a displacement positive and negative. Okay, so this one I want you to copy. Okay, O is a fixed point. Movement of the particle to the right is positive. Okay, then the velocity positive meanings what? The particle move to the right. Okay, if the velocity is 0, meanings what? Meanings the particle is at rest. Okay, stationary. This word all the words are stationary rest Okay, it means that V equals to 0. Okay, next, velocity is negative. Okay, meanings what? Meanings that the particle move to the left. This one you copy. Okay. Okay, now we see what is this meaning of an instantaneous velocity. Same like just now, they will give you a function. Okay, you see the V. Okay, the velocity they give you in the function of the t. Okay, same thing. Just substitute the t. Depends on the question, what the questions want. Okay, we go to these questions. A particle moves along a straight line. You see again, the same sentence they used to start the questions. Move along a straight line. Again, a particle. Okay, passes through a fixed point O. Okay, velocity passing through the point O is given by this. Okay, calculate the initial velocity. You must understand the terms, what is the meaning. Then you can solve it easily. Okay, initial velocity means the velocity at the beginning. Beginning means when t is 0. All this is like reading books, you know. If you can manage to get a very short notes by yourself, all these keywords will help you. Okay, before you sit for exam, okay, revise one more time for your notes. This question actually can do. Okay, if not the K-bar type of question, if not the two particles type of question come out, this question can do. Okay, so initial velocity when t is 0, just substitute t is 0 here. Okay, the velocity is negative 12. Okay, number 2, the instantaneous velocity of the particles when t is 5. You see, so simple. Just substitute t is 5. Get the answer. V is 3. Finish. Okay. Number 3, the time in second when the instantaneous velocity in a meter per second of the particle is 6 meters per second. Okay, so they give you V. They're asking for the T. Okay, so just replace it. The V is 6 in these equations. Get the T. Very simple. Okay, the part A, the 1, 2, 3 is like giving you bonus mark like that. Okay, but B, velocity time graph. Now the graph is different. Just now is displacement time. Now is time. So here is the velocity V. Okay, based on this equation, you see no square. So this is a straight line. Straight line, very easy. You need 2 points, finish the story. Okay, so you can use the first point, 0, t is 0. You can use the last point, t is 6. Okay, so all the information is here. T is 0, v is -12, 1 point. Okay, when t is 6, oh, luckily you have it here. Okay, then the v is 6. Okay, 2 points. If you want, okay, one more point is you find the x-intercept or the t-intercept here. Okay, so when v is 0, okay, what is the t? Okay, when v is 0, try to find what is the t. Then the whole graph is perfect, complete. Okay, so 3t minus 12 is 0. Okay, therefore 3t is 12, then t is 4. Okay, so you just need one more point, 4, 0 here. Okay, straight line, finish. Okay, so this is the graph. Okay, now we come to last part already. Accelerations. Okay, we continue. Accelerations are A is the rate of change. Again, rate of change. So, okay, here the acceleration is denoted by A. So A rate of change again over dt. Okay, it's a rate of change of velocity. Okay, so dv over dt. Okay, this is accelerations. Okay, same thing. Okay, because velocity is a vector quantity, therefore acceleration also is a vector quantity. Okay, then another one is you have to know what's the meaning of a uniform acceleration and non-uniform accelerations. Okay, uniform acceleration is okay the rate of change of velocity with time of an object that it moves is same at any time. Okay, example, a equals to 5. Means no matter the t the time the t is what it also will not affect it. The a is always is 5. This one we call it uniform acceleration. Okay, then what happened to the non-uniform acceleration? You can write an example here. A equals to 5, let's say, minus t. Then this one is related to a time. Okay, different time you have a different acceleration. This one we call it non-uniform acceleration. Okay, then next. Okay, what is the meaning of the instantaneous acceleration? Same like just now. Instantaneous displacement, instantaneous velocity. Okay, so it's also refer to the certain time. Okay, and then it's also same like just now. Okay, so if you have a velocity time graph, okay, the gradient, okay, because a is dv over dt, so the gradient of the velocity time graph will be the acceleration. Okay, gradient of tangent, okay, of the acceleration of the of the velocity time graph is the acceleration. Just now the first one, the gradient of the distance time graph is the velocity. Now, the gradient of the velocity time graph is the acceleration. So you see, all are related. Okay, let us look at this. Okay, you see this graph, velocity time graph, velocity time graph. Okay, and then this is quadratic, different from just now. Just now is the velocity time graph is a linear graph. Okay, this is quadratic. Okay, but don't worry. Okay, you still can do one. Okay, so you look at this graph. Same thing, same like just now. This part. If the curve is something like this, okay, the gradient is positive. Okay, so from the time 0 to 2, the gradient is positive. Okay, the gradient of the velocity time graph is the accelerations. Okay, so the first one, the first dot here, for the time interval 0 to 2, okay, not including 2, the gradient of tangent positive. Okay, so the acceleration is positive. Okay, v is increasing. Here, the velocity is increasing. Okay. Then when at t equals to 2, the maximum point, same thing. Here, okay, the acceleration is 0. Okay, at t equals 2, the gradient of tangent is 0, okay, which is a equals 0. The velocity v is maximum. Okay, then the acceleration is 0. Okay, 0 acceleration does not mean the velocity is 0, but rather it is either maximum or minimum. Okay, so remember, 0 acceleration not means the velocity means the velocity is 0. Not means the particle is not moving. Acceleration 0, the particle is still moving, maybe. Okay, we don't know. Okay, but at that time, the velocity is maximum or the minimum. This is a minimum. So all these are the concept must be very clear. Okay, third point already. Okay, how about when t is 2, greater than 2? Okay, you see the graph is something like this. So here the gradient is negative. Okay, for t greater than 2, the gradient of tangent is negative, which is a is smaller than 0 and v is decreasing. Okay, then the acceleration is negative. Okay, you also, when the acceleration is negative, another words you can say is called decelerating. Okay, or deceleration. Okay, because acceleration AC, okay, this is DE, decelerations. Means it coming down, okay, not speed up but slow down. Okay, deceleration means slow down. Acceleration actually means speed up. Okay, so means if acceleration negative, you also can say that deceleration. Okay. Okay, and then in general, this one, okay, this one you can copy. Okay, a is positive, meaning velocity increasing with time. A is 0 means velocity is either maximum or minimum. Okay, A is negative means velocity is decreasing with time. Okay, so it's quite simple. Okay, now we go to example 4. Okay, same thing. You see, this question not difficult. Okay, they give you acceleration as a function of t. Again, same thing. You see the question start with this sentence. Okay, a particle move along straight line, passes through a fixed point O. Okay, then the acceleration is given by this function. Calculate the instantaneous acceleration of the particle when t is 7. Just replace the t with 7 here. Okay, the answer is negative 16. Okay, so the negative value, you look at this, negative value means what? Of the acceleration show that the particle is slowing down or decelerating. Okay, okay, so this one you do as homework. Hey, are you still there? I'm talking for don't know how long already, like 1 hour already. Nobody respond to me. Say, hey, teacher, hello, teacher, like that. I don't know whether I'm still with you.
Hi, teacher. You are still with us.
Thank you. Kritika? Is it Kritika?
Yes, it's
You fall to
me.
sleep already, not?
No lah. I eating and also enjoying your lesson.
Okay, so how do you think you can do this chapter? Out of the 4 chapters, do you think you will do
I
this
can
chapter?
do, but then because of the integration part, gone.
Hey, all very simple only, no?
Yeah,
All
but
the
then still I
all
tak
the
bagus
function all very
integration.
simple. You just remember differentiation is the power down, integration power up.
Up.
Integration power up. Differentiation power down.
Hold on. So far, this chapter okay. Just apply chapter 2 and chapter 3 in this chapter.
It really, you confused about that differentiation integration also, go through the question. In the case, Mana Tao, this question, they come out senang one, You know, you see, like just now, T is what? You just replace in the formula, and then, you know, Mana Tao, you get 1 or 2 marks.
Yeah, true.
Okay, let me continue. Okay, this is the last part of today already. Okay, I also no energy because my hand using the mouse ayo, until like my hands cannot, my finger cannot move like that, like the finger not belong to my finger.
Teacher, you're drawing with mouse
Yeah lah, you don't see
Oh
I
my
write so slow
God.
and then so ugly today.
Oh no, teacher, I usually think that you're drawing with the thing, the pen thing.
I told you already early, the digital pen give me problem. You know, early morning I have a Form 5 class with a Pinta modern maths. Ayo, in out so many times because I didn't know it's my pen problem. So I borrow my son laptop some more, then try again. Still also cannot. Then my daughter tell me it's the pen problem. It's not the laptop problem. It keep my laptop, it will auto keep restart one, like
I
other hunting like that.
see.
So
I think
I
the
don't know what
pen,
is
the
happening.
battery problem code the pen.
The pen not use battery one. Whoa. Yes, got battery. Okay, after that I go and check. I don't think it's you battery because it chocho the USB one.
Maybe is it the charging one?
No, not charging. No need to charge at all.
Or that means the inside maybe something already Rosa code. That's why you don't want to connect properly.
This is my lovely pen though. Without this, how do I write? I
Teacher,
have to write.
memang so painful to draw with mask. Once I tried for something, I died really.
I don't know. Okay, one more example. Okay, this one is regarding the distance traveled. Okay, like just now, I got give you one example for distance traveled. Okay, so you see this question. Okay, a particle move along a straight line from a fixed point O. Okay, again you see, always the question start with this sentence. Okay, particle along straight line from fixed point O. Okay, so the displacement is given by this function, quadratic function. Okay, find the total distance. Always the question will ask this type of questions. Okay, so be careful with the displacement. This is distance. Okay, total distance traveled by the particle in the first 7 seconds. First 7 seconds. Why I highlight the first? After I will tell you why. I better highlight. This one not nice. Highlight. Okay. First. Okay, so let us start. Okay, actually this question they didn't ask you to draw the displacement time graph. Okay, they didn't ask you to draw. They just want to know the total distance. So for this question, I will not do anything for the graph. Okay, I will not do the table. Okay, I will do only number line. I will prefer the number line. Okay, for these questions. Okay, unless the question asks you to do the displacement time graph, then you have no choice, you've got to draw the graph. Okay, so how to do these questions? Okay, same thing, first 7 seconds. So you have to know when t is 0, what is the s? Okay, and then the ending when t is 7. Okay, and then what is the s? Mean where is the position of the particles? Okay, and then one more thing, when it turns, I need to know when the particle turn and then change direction. Okay, so the particle will turn when v is 0. So remember, the particle very cute one, no? It will rest when v is 0. It rests, okay, not move, It rests for a while. Okay, after that, it will change direction. You have to remember this one. Okay, so I need to find V is 0. Okay, V is what? Just now we say already, V is ds dt. Differentiation, no? Okay, so differentiate this. Okay, differentiate t squared. What do you get? 2t. You see all the differentiation, very simple one. Okay, differentiate negative 6t, you get negative 6. Okay, let it equal to 0. I need to know the time. Okay, when it will rest for a while. So here is 6. Okay, then t. So t is 3. Okay, so you see, quite simple, no? I just need to find 3s. Okay, when t is 0, t is 7, and t is 3. Okay, I just need to find the s. Okay, I copy the answer from here. I'm lazy to find. So when t is 0, s is 0. When t is 7, s is 7. And when t is 3, okay, s is negative 9. I just need these 3 things. Okay, now you see the number line. Okay, when t is 0, okay, put here 0. Okay, maybe you ask, hey, teacher, how to start with this number line? Okay, now I draw for you. Okay, you see what point I have? Okay, s is 0, s is 7, s is negative 9. Okay, so quite simple. I draw it here 0. Okay, 7. I mark here 7. Okay, negative 9 on the left hand side. I mark here negative 9. Okay, like this only. Okay, so you don't have no so complicated one. Look like the textbook one. Not need to so complicated. So now we start already. When t 0, s 0. So you mark 1 point here. Okay, you write t 0. Okay, after that, after the t0, you don't go t7 first, you have to go t is 3, Okay, t is 3 is negative 9. So means from here to here. I don't care t is 1, t is 2. I don't care. Okay, t is 3. Okay, the particle is at negative 9. It's at here. Okay, after that, okay, if you don't want to draw up, down like that, you can draw this way also. Okay, until here, it will turn. The particle will turn. And then it stops at 7. Okay, so from T0 to T3, the direction this way. Then after that, the direction will be this way. Okay, so here end with T is 7. For me, my number line will like this. Okay, simple. No need to label everything 1, 2, 3, 4, 5, 6, 7. No. Okay, I just get the key. Okay, then what is the total distance traveled? Okay, I use another color. Okay, from here to here. Okay, 0 to negative 9. This is 9 meters. Okay, then from here to here, negative 9 back to 0, another 9 meters. 0 back to 7 here. This is 7 meters. Okay, therefore 997. So this is the answer. Okay, 25. Okay, and then one more thing. You look at this. Is the distance traveled in the first 7 seconds same as displacement at the 7 second? Displacement at the 7 second, the answer is 7. But the total distance traveled in the first 7 seconds, the answer is 25. Very different. Okay, never be the same. Okay, one is displacement, one is the distance traveled. Okay, cannot be the same. Okay, but another question, another type of question, you have to be careful. Why? Just now I highlight first 7 seconds, because the other type of question they can ask is this way. The distance is traveled in the 7 seconds. Means at the 7 second, how to say? At the last part only, they want to know at the 7 second, what is the distance traveled. They are not interested from the times from 0 until 7. They are only interested on the 7 second. Okay, what is the distance traveled? This is the meaning. So I highlight 7 seconds. Okay, the first 7 seconds and alert. What happened? I want to cry. Okay. I still want to highlight. Okay, the first 7 seconds, okay, and the 7 seconds, they are two different things. Okay, so I write here, first 7 seconds means the time, okay, the distance traveled is from the time 0 until 7. But if the question asks the distance traveled in the 7 second means, okay, the time is 6 to 7 only. Means at the last 7 seconds. At the last second. Okay, what is the distance traveled? Okay, can see different. Okay, so this is very important. If you are writing notes, these two, okay, must be inside your notes. Okay, distance traveled in the first 7 seconds and the distance traveled in the 7 seconds. Different meaning. Okay, so this one got formula. S7 minus S6. Okay, you put modulus is because if the answer end up with negative, you just make it positive. Okay, so in this case, S7, the answer is 7. Okay, S6, the answer is 0. S7 means when t is 7, what is the S? S6 means when t is 6, what is the S? Okay, so the answer, this one is 7. Okay, so this is another homework. So today you have a 2 exercise. Try and see. Okay, any problem, let me know. Must try. Okay, because not many questions. Here 2 questions, here 3 questions, altogether 5 questions. And then I guess it's all are quite simple, you know. Okay, just substitute inside. Okay, see whether you can get answer. But some are maybe difficult one. You can ask me during the next lesson. Okay, so wait, I have to stop recording. Before I end, anything you want to ask?